First of all, if anybody who already know like what is that simple linear regression, so can you just tell me like what is the simple linear regressions? If you know, like just pause the video and just write the answer first of all. First of all, write the answer. Okay, then after that you can just play the video. Right? Okay. So listen. Let me revise that one. So as you know that machine learning, the machine learning is divided into let 4 type, but I'm just writing that supervised and unsupervised and unsupervised machine learning. Again, supervised is divided into regression and then classification. So hence, this regression part is nothing but what? It's like the output is always continuous. Or you can say the real value. You can say that real value. So now let us understand, means like while taking an example. For example, so if I have data set, I am having the data set. I'm having the data set. One data set is here. Okay, one data set is here. So while taking this data set, this data set is the trained data set. Let this data set is the trained data set. So I'm just taking this trained data set to create one simple linear regression model. Okay, I just train this model. I just train the model. And after that, this model will be generate what? This model will be generate the hypothesis. This model will be generate the hypothesis. So here we will just give some new data. Here only we will just give the new data because already the model is already trained here. Okay, we'll just give some input data to the hypothesis part. Then hypothesis will return the output. It means what? Always remember, you can just write one notes also as a note. So it means what? So we are getting the predicted value from the hypothesis. It means what? So this output is nothing but the prediction part. It means what? We are getting the predicted output in the hypothesis. Clear, everyone? Good. So now move to the next one. So let assume that let me just draw one graph. Simple linear regression graph. Okay. So here, let assume this one is like a one data point. One data point, this one another data point. Oh, this one the data point and data point, another data point. Okay, so like this the data point is there. Okay, so now if I will just draw one line, so this line is nothing but the hypothesis line, you can say. Please just write in your copy each and everything. You have to just write. These all are the scientific name. Okay, so here this line I'm just drawing like what for what means this line is nothing but these are the real data set. These are the real data point. Okay, these are the real data point, and here this line is like I just draw like average of the data point, means maximum. My aim is what? My aim is like to minimize the error part. Okay, so you will understand what is the error part. But think, listen. Point is what? Like you have to like draw one line so that this line is indirectly known as the predicted line. And remember, predicted line. And remember, the black dots are nothing but what? The data points. And here, this one is the x-axis part, and this one the y-axis part. And remember, this part is nothing but what? This part is nothing but the predicted part. So according to the x-axis, so we'll just predict that one. So here x-axis, this one is what? You can say that, listen, this one, you can also say that this part is nothing but what? So dependent part. And now this part is what? Independent part. So now, can you just tell me which one is the dependent and which one is the independent part? Yes. If you know, can you just tell me which one is the dependent and which one is the independent? So let this one is the one data set. This one is the one data set, right? So each data set having what? Each data set having one column. Assume that I'm just taking the example of whom? I'm just taking the example of, let me just write the data set. This one is the data set. So I'm just taking that healthcare related example. So first of all, understand deeply what is the data set. Because if you're just working with the machine learning, that first concept means always one concept is coming like what? You have to work with, at the end, you have to work with the data set. So that data set can be in any format. That can be in like CSV format. That can be in like Excel format. Okay, totally depends upon like what type of data set. It does not mean like you can also convert to into like CSV format. Don't worry. But point is what? We at the end, our aim is what? Like we will just work with. We want to just solve. We want to just find the hidden pattern inside the data set. So here, if I will just work with like healthcare problem, like assume that healthcare problem is what, like what? Yes. So I'm just taking that heart disease part. Heart disease prediction. I'm just doing, let assume that I'm just doing one project, heart disease prediction. So here in the heart disease prediction, so there is a name of the person. The blood pressure is high. If there is a high, then it will be yes. If blood pressure is low, then it will be no. Okay, so then what is the cholesterol? What is the calcium level? Okay, what is the okay, each and everything. Okay, so now what is the blood group? Okay, everything. Okay, everything. So what is the fever? This one you can say that fever is there now. Okay, everything. So then after that, many things there. Okay, so I don't have any idea related to like healthcare. Okay, but think that okay, so there is each and every symptoms are there. Each and every symptoms are there. So these all are the symptoms, you can say. Symptoms. Okay. So then according to these symptoms, then at the end there is a one target variable. That target is nothing but what? Whether that person is like suffering from the heart disease or not. It can be in like in this like this what 0 1 1 1 0 0 0 1 1. So here 0 indicates that what? So yes, that person is not suffering from the heart disease. But here one represent or one shows that yes, that person is suffering from the heart problem. Clear? So hence here in this data set, which one is the dependent variable and which one is the independent variable? Yes. Can you just tell me which one is the dependent variable and which one is the independent variable? So here the result is depend upon whom? The result is depends upon each symptoms. The result is depends upon each symptoms. So hence each symptoms is known as what? So each symptoms is known as the independent variable. Clear? And now the target value, this target part, the target column is known as the dependent variable. Because as your result is always depends upon like how you perform in the 3 hours examination part. So we are not worried about like how you are like perform in that 4-month preparation for the upcoming semester. So our aim is what? Our goal is what? That experson, how or he or she like performing in that 3 hours examination part. Clear, everyone? And then that 3-year examination part is also depends upon whom, like how you are like preparing yourself for this exam, 3 hours exam. Like there is a lot of subjects, like some of the subject in there. For example, you in this semester you have 5 to 6 subject, right? So you can just assume that each subject is one on features, you can say. Also one scientific, listen. So right now from today onwards, so you will just hear one new scientific name from my voice. Okay, so here this each column is known as what, you can say that attribute, and also this one is also known as what, features. So whenever just you will hear about like feature selection part, okay, so at that time just think that these are the features part. So whenever just you will work with like r squared, adjusted r square, okay, so then you will just know all these things. Now clear? Which one is the independent and which is the dependent? Good. So now next point is what? So this one is what? I think you already know. This part is hypothesis. Hypothesis work is what? So we will just provide the new input data and he will just predict that one and give the output. Either it is in S format, either, or else it will give in the no format. Assume that there is a new data which is enter, and let us assume this is here. Now I want to know, I already create my model. I already train my model. Train in the sense what? I already provide the data, and according to that data, one best line which is like provided. Okay, so if I want to like predict that data, this data hypothesis line is red color line is also not known as the predicted line. Okay, so here I want to like what is the new data output. So here what we have to do, like we have to draw like this, and so this part is the output. So let us assume 1 and 2, then 3. So in the feature 2, so the output is what? Let us assume 1. Clear everyone? Clear everyone? So whenever any new data which will be like move to that hypothesis part, so it will be predict like this. And do you know, while looking at to this one, so we are like yes, maybe you have clarity, but whenever just you will jump to that mathematical concept, then you will like much more clarity. Okay, so in that time, so while like moving to that depth concept, you need to know like correlation part. There is a Pearson correlations, Spearman correlations. So it will be help you out to find out these things. So I will explain each and everything, but please just maintain your role. Means like note, copy, right? Good. So this is the concept. So this is the point. Now next point is what? So here, let me just move to the next slide. Now, so here, I'm just giving one notation part. Means like I can't always write like hypothesis always. Okay. So always like in mathematics, I think you already know. So if there is a very big name, so you have to like provide one notation part. So here I'm just giving that notation to the hypothesis. To the hypothesis that what? This one is the H theta. H theta. So here H theta x is equal to what? Theta naught plus theta 1 and x1. So please don't be confused. So here this theta is what? the data points, you can say. And here, this x1 is what? The features. So as your feature will be increased, then you can just write, means you can just increase all these things. Clear? So now we'll understand also like how we will just calculate the hypothesis part. How we'll just calculate the hypothesis part. So here you can say that so according, like while moving to that graph part, so here this part is the y and this part is the x part. Okay, x part, and you already know like so in the simple linear regression, so our goal is what? Our aim is what? Our aim is like to create the or to draw the best fit line, so that our model will be predict very accurately. Clear? For example, okay, listen. Assume that another concept is left. Let me just explain that part. Then after that, I will move to that calculation part. So if there is a one graph and there is a one data point. Okay, one data point is there. These are the data points. Okay, so now according to this data point, so I'm just one line, and this line is nothing but what? Predicted line. Okay, predicted line. So now can you just see like this data point is already like in the line which is cross to this data point, but one data set is there. There is a one difference, there is a one gap is there. Yes or no? There is a gap or not? So this gap is nothing but what? Residual error. Now clear? So whenever just I'm explaining that part, so our goal is what? To minimize that error. To minimize that error part. If we'll just draw perfectly like line, the error will be what? Very minimal. So now maybe in your mind, the question will become like, sir, can you just explain how to just find the error? Arey beta, listen. So here, this black color data point is nothing but the actual value. But here, this line, this one is what? Predicted value. Predicted value. Clear? Predicted value. So if you want to calculate that error part, so you can just subtract these two things. So actual value, negative predicted value. So that difference is nothing but the residual, you can say. But the point is what? So we will not calculate the error like this. We will not calculate the error like this. Okay, will not calculate. So there is another concept is there. So I will explain that concept. So let's move that. So before that, before explaining that concept, so let me just give another example so that maybe you will just get this clarity. Okay, because my goal is what? To make very easy all these things for you. Okay, so let me first draw one graph. One graph is there. One graph is there. One graph is there. And now here in this case, and you already know, in this case, you already know, like wait. So, okay. So here, these, so I already know the H theta x is equal to theta 0 plus theta 1 x1. And you know that this theta 0 is nothing but what? Intercept value. And this theta 1 is what? Slope, or you can say the coefficient value. Okay, you can say that coefficient. Clear? So here, this now we are predicting. The hypothesis is nothing but what? The hypothesis is, what is the role of hypothesis? He will find out the output. You will just find out the output, and that output is nothing but what? Hypothesis is what? Predicting that output. Predicting that output. Clear? So now, for example, so here, one point is that, means like, if theta will be 0, so now let's go for the mathematical part. If theta 0 is equal to 0, so now here let assume that, okay, so let's take an example like okay, let take 0.5, okay, 0.5, and theta 1 is equal to 0. So now how to calculate? So how we will calculate? So first of all, what we'll just do? Yes. So first of all, we'll do like this. Theta 0 equals 0.5 plus what? So theta 1 equals 0 multiplied anything. 0 multiplied anything is nothing but the total is 0. Yes. So it is giving what? The predicted part is nothing but the 0.5. The predicted point is nothing but what? 0.5. So once if theta 1, so this part is nothing but the theta 1 and this part is a theta 0. So if theta 0 is equal to, this one is the 1.5. If theta 0 is equal to 1.5 and theta 1 is equal to 0, then the line will be drawn like this. The line will be drawn like this. But in case of whom? In case of this one. So here what happened? Here what happened? If theta value, if theta 0 is equal to 0 and theta 1 is equal to, let 0.5, then what it will be happen? Assume that I'm just giving like this one is the 1 and this one is the 2, this one is the 3, this one is the 4, similarly 1, similarly 2, similarly 3, similarly 4. So now what will be happen? So let's calculate. So if h theta of x is equal to theta 0 plus theta 1 and x1. So here theta 0 equal to 0 plus theta 1 is equal to what? 0.5. In case of which feature? One feature. So now 0 plus 0, 0.5 multiplied 1 equal to what? 0.5. Now answer is what? 0.5. Now just tell me. So in the case of theta 1, the place of the theta 1 and this one is the theta 0. So what is the theta 0? Theta 0 is, sir, theta 0 is nothing but the 0, sir. So what is that theta 1? Theta 1 is nothing but the 0.5. Then the data's point will be like this. Similarly, go for that next. What? H theta x is equal to, so theta 0 plus theta 1 x1. So then if there is a 0, so let me just update to what? Update to 1 part. So now here like whenever just we move to like next feature, then it will be like what? Then it will be, you can say that 0.5, then 1. sorry, two part is there. Sorry, one is gone. Let's go for the two. So if we will move to the two part, then in the two part, so what we are just getting? So can you just tell me? Yes, 0 0.5, 0 0.5 multiplied 2 is equal to what? 1, 1.0. So it means in this case, the data point will be looking like this. Similarly, you can go for that h theta for the 3 case. It means what? 0 plus 0 0.5 of the 3. Now, what is the output? 1.5. So, in the case of the 3, 1.5 is where? 1.5 is here. Similarly, for the case of what? 2. Okay, like this. It means what? It means what? The line will be drawn like this. It is what? Straight line. Okay, it is straight line. But point is what? So this is the best line for this case. This is the best line for this case. But the point is what? But in this case, in this case, what will be happen? If there is a multiple data point is there, multiple data point is there. So while how I will just draw the best line? So maybe you will just try like to draw like this. Okay, so this one is the best line. But point is what? Maybe you can just draw, like this. How? Maybe you can just draw like this base fit line. But maybe you can just draw. How? Maybe you can just draw like this. But point is what? Point is what? So here we want to like continuously just searching for the best fit line. Should I do like this? So the algorithm model will be means like continuously like searching for the best fit line like this? No, better no. Why? Okay, can you just tell me why just they are just searching for the best fit line? Because our goal is what? Our goal is what? The summation of actual and predicted errors should be what? Minimal error. The summation of actual and predicted errors should be minimal. It means what? The line start from one point. But here one point is what coming here. If I just draws any line, means if I just moving to any concept like so you are just drawing like this line. Okay, this is the first line. But point is what? There is a one error, there is another error, there is another error. So these are the what? These are the error. So your goal is what? You have to minimize this error. So that's why you are continuously just what? Drawing all this line. But can you just tell me, if we'll just draw this line, can you just check this error part? This is a very big error. For this pink line, if I'll just change the color, for this pink line, can you just check this one? This is a very big error. So while solving to this error part, maybe in your mind, sir, can you just tell me, is there any solution? Is there any solution for this problem? Yes, there is a solution. There is a one hero. There is a one hero whose name is what? Yes, can you just guess whose name is that? The name is nothing but the cost function. So now the hero is what? Entering in the middle of the movie. Now cost function is coming and entering. Okay, so please don't worry. I'm here. I have some of the like algorithm, sorry, some of the technique. So I can just calculate your error part, and I can also like to help you to create that or to draw that base fit line in your model so that you can just predict perfectly. Are you getting? Are you getting what I'm just trying to explain? Clear? So here the cost function will be help you out. The cost function will be help you out how to just like reduce the error part. So here, similarly, so these are nothing but this hypothesis line is also nothing but the slope. Means whenever just you are like moving towards like the cost function part. So there the cost function formula is what? The cost function formula is nothing but so summation, sum of like 1 to m, the data point. These are the datas. These are the datas which is present inside the data set. M number of data set are there. Whereas 1 by m and h theta of hex, this is the actual data, negative of predicted data square. Why square? Can you just tell me why I'm just giving the square part? Because I will never accept that negative part. Maybe in somehow in some case this part is the smaller value and this part is very larger value, and the answer will become in negative. So I will not take that negative part. So that's why I'm just taking what? That square part. Clear? So here, this formula will be what? So whenever just you will mathematically solve this formula, so you have to just like what? Differentiate. So while differentiating this one, so I'm just moving to what? Keeping this value 2. How to differentiate? How to differentiate? Let us assume that this part is like t square. So differentiate of this t square, d by dt of t square is equal to what? So 2t of what? 2 minus 1, whereas 2t. So if you will just differentiate these things, so the 2 will become automatically, it will be minimized. This 2 will be cancelled out. And hence, now you can get in what I'm just trying to explain. So this is the formula to calculate the cost function. To calculate the cost function. Means if we'll just move like here, cost function is denoted as what? So there is also another notation. There is also one notation is there. What? So j of theta 0 and theta 1. So which is equal to what? So half. So sum of m data point are there. So now h theta of x I, y of I equal to square. So now this one is the formula for the cost function. And do you know the other name of this one is what? Squared error function. It means what? This cost function formula, this cost function can be called as squared error function. Okay, so here what is, so in the previous part, so what we're just doing, you are continuously, this one is the theta 1, you are continuously changing the theta value. You are continuously changing the theta value. Continuously changing the theta value. Because of what? Because to create the best fit line. Because to make the best fit line. Right? Are you getting my point? So if any new data will be formed, like assume that, so there is another data point which is like coming here, and here how we will just predict? We'll just predict like this. We'll just predict like this. So here for this case, the output is what? The predicted value is what? This part. How it is coming? Because of this best fit line. So this line is known as what? Hypothesis. And also is also known as what? Predicted line. This hypothesis is giving what? Some output. And that output is nothing but what? The predicted output. By whom? By model. So who is training the model? So we human are just training the model. While taking help of whom? While taking help of the data set. So we are collecting the trained data set and just we're just providing the model, and the model will is what? The model is what? Yes, yes. So let the model will be what? The model will be fully trained, and then it will be generate one hypothesis. If we'll just provide, finally the model is trained, if we'll just provide any new data, it will predict the output. And hence, I think you already know, like whenever just you are doing any machine learning project, okay, so you are just focusing on that accuracy part. What is the accuracy? That predicted part, that predicted outputs value should be correct at this percent. If you get accuracy like 80 to 90%, your output value will be 90% correct. So here what concept is coming? Here what concept is coming? What type of mathematical concept is coming? The probability mathematics is coming. We are just doing what? We are just predicting that part. The predicting concept or the predicting name comes from what? Comes from the probability. So hence, now understand, if we're just moving towards the machine learning part, so you need to like master in the probability. Clear? That is the point. So for today class, so that's all. So from tomorrow, next class, for the upcoming video, so I will just give like explain the difference between, okay, so once you will just understand the relationship between the hypothesis and the what, that cost function, once you understand that part, then the game is over. Then after that, I will just provide one mathematical calculation part, how the model will be working, that backend part, how it will be working in the mathematical part. So once you understand that point, so all these things are what? Bayat ka khel. Clear everyone? So for today, so that's all. So please just like you have to like whatever things I just explained. Okay, so please just maintain your note copy, and you can just take any resource also, take help of any resource, or else need not like take any resource for the gate. So this much like knowledge is very enough. Okay, so you have to practice. If you are just getting like any doubt, so please just again you have to just revise, like again you have to just replay that video. Okay, so if I'll just talk, like there is a one book is there. So first time you are just reading this book. So one new idea you are just what we are getting, because first time you are just learning now. It's 100% sure. First time you will never just gain 100% knowledge from this book. 100% of the idea you did not gain from this book. Second time you have to just read. Whenever just do a second time you are just reading now. So in that time, again you are just getting another new concept. Similarly, again if you just read same book, again you will just get another concept. Similarly, if you just revise that video, if you just revise that concept, okay, then the time will become, you will just familiar with all these algorithm. So now, so in this today, so before this today class, you don't know what is the simple linear regression. But if anyone who will just ask you, can you just tell me what is the simple linear regression? So what should be your answer? Sir, the simple linear regression is nothing but what? So we're predicting one line, and that line is nothing but the one of the slope. So that slope is presented. Okay. Oh, so I'm not explaining that point. So why we're just doing that differentiate part? Because the differentiate part will be what? That differentiate part will be what? So it will be to find the slope. It will be help to find that slope. Clear? It will help to find the slope. So now we will just create that hypothesis line, and that hypothesis line is the what? Predicted line, and that line should be best line. How it will be best line? How it will be best line? So we have to minimize the error also. How to minimize the error? With the help of the cost function. Clear? Is that clear? Is there any doubt? So if you're having any doubt, so please go to the description part. You will just find that WhatsApp group link, and you can just easily join through that link, and you can just directly ask the question to me. Okay, or else it should be very, very better. So please do like give the comment. Okay, ask the question in the comment, so that if I'll just ask any question in the comment part, so if anybody who is just visiting my channel first time, maybe in that comment session, so maybe he or she will be like find that same question, maybe that question will be help to them. It will also better. And please just behave like a means reinforcement algorithm. Okay, because I'm just putting a lot of energy, so you have to give me the reward. The reward is nothing but what? Like, subscribe, and share. That's it for me. Clear? So because it will be keep motivating me. So what for today class, the simple linear regression is not completed. So tomorrow I will just provide you the real mathematical things. So tomorrow you are just going to what? You are going to enjoy this class. So this is the trailer. This is the trailer. Okay, so don't worry. So that's it. So for today, that's it. Okay, so please just revise all these things. Okay, so and then after completing the simple linear regressions, you can just go to that get a sample paper. You can just search the question related to this concept. So likewise, you have to prepare yourself, right? So that's it. Bye bye.